All right, we're going to go ahead and talk about quadrilaterals and parallelograms. First thing we want to do is look at our warm-up. Our warm-up is going to go back to our angles of polygons in our previous notes. We're going to find the measure of each exterior angle. Very important to highlight that so we know we're looking at each in exterior. And we're looking at a regular heptagon. We want to round to the nearest tenth. Okay, that's what we're going to be rounding to. Now with a heptagon, we need to remember all the way up to at least a decagon, how many sides between a triangle through a decagon, how many sides we have. Heptagon, remember that n is the number of sides. Heptagon is going to be 7 sides. Now each exterior angle, because of that each, we're going to have to take the sum and divide it evenly amongst every single angle. So we know we're going to be dividing. So we have to figure out, okay, exterior angles. Well, if we look back at our previous notes, we talked about exterior angles, we realized through observation here that the sum of our exterior angles is 360. And we worked out a couple problems, and down here we looked at, okay, well, technically the formula for each exterior angles, you just take 360 and divide it by n, the number of sides. So we could put here 360 divided by n as our formula, leaving us with 360 divided by 7. When we divide this out, we round to the nearest tenth. We're going to wind up with 51.4 degrees. Now we move through into the more specific polygon that this chapter is about, are quadrilaterals. Your generic quadrilateral and every other type of four-sided figure that's going to fall underneath the category are going to have the same 2 properties, and these are the only 2 properties that this polygon meets. This is going to be that their angles are going to add to 360 degrees, and that as quad in the word quadrilateral means 4, we're going to have 4 sides. And that's what we have over here. Naming a quadrilateral is not like a triangle. A triangle, you could choose all 3. You can take all 3 vertices, angles, letters, and you can put them in whatever order you feel like it. In a quadrilateral, you cannot do that. The only 2 options you have that you get to choose from is what letter do you start with, and do you go clockwise or counterclockwise. But you have to start with one letter and go consecutively clockwise or counterclockwise. So there's several different ways that you can name this quadrilateral. We'll start off with starting with the letter A. We can go clockwise and call it A, B, D, C. Notice it's not in alphabetical order. Okay, A, B, D, C. And you can also go counterclockwise, A, C, D, B. Okay, you don't have to start with A. Let's start with D. We can go clockwise, D, C, A, B. You can also go counterclockwise. You can start with B. Let's go counterclockwise on it, B, A, C, D. And hopefully you're picking up on that pretty simple rule about how to name that quadrilateral. Start with one. This is going to be quadrilaterals and up. Even your pentagons, your hexagons, heptagons, you start with one and you go consecutively clockwise or counterclockwise. So with those, only the 2 properties that a generic quadrilateral has, we're going to identify if these are going to be quadrilaterals. We're going to circle the one or ones that are quadrilaterals. If you look at A, well, we have 4 sides. We can easily see that 1, 2, 3, 4. So check that one off, but we have to check to make sure that the angles add up to 360 degrees as well. So if we take a look here, if we just take this, I'm going to go ahead and circle this. Actually, I'm going to go the other way. That way we can see it mathematically. If we take 90 plus 70, we're going to find out that this is going to equal 160 degrees. And then if we take the other 90 plus 70, this is also going to equal 160 degrees. If we add those 2 together, we're going to find out this is 320 degrees. So this is not going to be a quadrilateral because they're not equal to 360 degrees. The angles are not. Take a look at B. 1, 2, 3, 4. All right, we got 4 sides. Let's check out our angle measurements. Here we have 120 plus 60, giving us 180 degrees. We have 60 plus 120, giving us 180 degrees. And there's several you probably already know, 180 plus 180. If we add these 2 together, we're going to get that magic number 360 degrees. So B is going to be a quadrilateral. Let's take a look at C. Well, automatically we have a problem. 1, 2, 3, 4, 5. This is not going to be a quadrilateral because it has 5 sides. We don't even need to add up the angles. Start with hey, how many sides do we have? And then continue on with then, what do the angles add up to? So now we're going to solve for our missing angle. So we're going to use the property of all angles add up to 360 degrees. So we're going to take the 90 plus the other 90 plus the 70 plus our missing angle will all add up to 360. Combine these like terms, we're going to wind up with 250 plus x equals 360. And then we just subtract that 250, solving for x like we're used to doing. And we're going to find out that this missing angle, x, is going to end up being 110. And that is our angle measurement. We move on to B. We're going to start off with that first process of adding all 4 to equal 360. But what I want you to notice here is they're asking us to solve for the missing angle. The missing angle is not just an x this time. So after we solve for x, we will have to plug back in. Let's start off with solving for x. Okay, I'm going to take this 47 plus the 100 plus the 60 plus the x plus 20, all equal to 360 degrees. When we combine our like terms, 47, 100, 60, and 20, we wind up with 227 plus x. Okay, keep in mind here, we have to know that the x is in between, but we do have a plus 20 over here. Okay, and then again, we do our subtracting the 227 from both sides. X is going to equal 133. Then we will take that x of 133. We will add 20 to get us 153, as my pen decides to die on me. Sorry, guys. That missing angle is 153 degrees. Okay, so moving on to parallelograms, we are looking at 5. We're going to add in a 6th property, okay, but new properties added to it. I'm going to jump to number 6 here first. All parallelograms are going to be under the quadrilateral category. Quadrilaterals is this entire unit from here on out. Everything we talk about will be a quadrilateral. So with everything we talk about from here on out, we'll also have that all angles add up to 360 degrees and 4 sides. All properties of, see if I can find the right page, of the 2 properties of the quadrilaterals, we're just going to add to it each time, okay? So in addition to these 2, the first new one is opposite angles are congruent. So what we're going to do is we're going to come over here to this parallelogram, and we're going to put a 1, telling us that it matches with the property number 1. And we're going to go ahead and put here that our opposite angles will be congruent. So these 2 angles will be congruent, and then these 2 will be congruent to each other, but not the others, okay? Property number 2 is going to tell you that opposite sides are congruent. So these 2 sides will be congruent to each other, and then the other 2 pair of opposite sides will be congruent. Next, we have opposite sides are parallel. So here, property number 3 listed here, we're going to have these 2. Remember, you either have the arrows or you may see triangles that you'll see down here, okay? And then we've got these 2 are going to be parallel as well. Property number 4, consecutive angles are supplementary. Consecutive, as we talked about earlier whenever we said, hey, naming the quadrilateral, you have to go consecutively, clockwise or counterclockwise. It's one after another. So what that means is if we say that this angle right here is 110 degrees, consecutive, one after another, this next angle right here would have to be 70 degrees because supplementary means 180. Same thing if we go counterclockwise from this 110, this angle would also have to be 70 degrees. Well, look at that. That also goes along with property number 1 where opposite angles are congruent. So that means this last one right here would have to be 110 degrees. Next, property number 5, your diagonals will bisect each other. Okay, what that means is when we draw in diagonals, we're going to go from one angle to the one across, the opposite angle, from one congruent to the, one congruent angle to the other congruent angle. When we draw in the second diagonal, it's going to bisect that first one. Well, the first diagonal is also going to bisect that second one that we drew in. Okay, so you have this property as well. Now, the next one that I'm going to have, you need to draw in your own parallelogram just the best you can real quick, because this is another property that is not listed on here, but we will be talking about, and we'll be discussing it more in the next set of notes. This property is going to be, we'll kind of put a little asterisk right here, that we're going to have one pair of sides. So you're not looking at both pairs of opposite sides. Okay, it's going to be one pair of, let's actually put on here, opposite sides. I'm going to put OPP for opposite. One pair of opposite sides is, sorry, I got to be grammatically correct, is congruent and parallel. Okay, so what we're doing is we're kind of taking property number 2 and property number 3, we're putting it together, but you don't have to say that both pairs are congruent and both pairs are parallel. What we can do here is say, okay, let's say that the left and the right here are congruent. Well, if the left and the right are also parallel, this will be a parallelogram. This is going to satisfy your parallel lines and transversals, giving you your opposite interior angles being congruent, which would then, your same side interior angles being congruent, leaving you as satisfying property number 4, that your consecutive angle, supplementary. Let me repeat myself, rewind. You're going to have same side interior angles. They will be supplementary, as I teach my students, same side supplementary, and that will satisfy property number 4, where your consecutive angles are supplementary. Okay, sorry, I had to change my paper because I forgot I had the wrong diagram on number 1. All right, so with 1 through 5, what we're going to be doing is we're not only going to be solving for what they're asking us for and filling in these blanks, but we're also going to identify what property is being used for these. Okay, that way we can get used to seeing what's here, identifying and memorizing these properties. Number 1, what we're going to notice is they use the triangles for parallel. And what we need to do is look up here at this additional one that we added in. They're on different sides. The one that we drew was on the left and right. The one on number 1 is on the top and bottom. It doesn't matter. It's still saying that one pair of opposite sides is both parallel and congruent. So right here, we'll go ahead and write that. Okay, so go ahead and pause it and write that in. So one pair of sides is both parallel and congruent, congruent and parallel. So what that means is x is simply just going to be 12. And what we can write here is we'll put the congruent sign. Here, because AB is congruent to DC, and this is a parallelogram, guess what, guys? Segment AD, let's go ahead and put that. Well, we don't have to put the equal sign instead of congruent. The length of AD is going to be equal to the length of BC. Number 2, what we're looking at are angles. So if we look at our properties, we only had 2 properties that talked about angles, and that's property number 1 and 4, where we had opposite sides are congruent, consecutive one after another are going to be supplementary. Well, here we're looking at angles D and angles B, meaning we're looking at opposite angles, and as we can see here with property number 1, opposite angles are congruent. So we'll go ahead and write in here, OPP for opposite. Angles are congruent. You're going to see me writing abbreviations like crazy. So please make sure if you don't know OPP, later it's going to be opposite, write out opposite. Please write the words out instead of the symbols if you need to. So that means if angle B is, here is x, that's what we're solving for, what's opposite angle is 70, x is simply just going to be 70 degrees. And here if we look, angle DAB, AB in the vertex, is congruent to, well, we need to find its opposite angle, BCD. Pause and rewind if you need to. All right, so in number 3, we're going to solve for both x and y. So for both of these, we're dealing with the sides. So we look back up at the sides. What do we know about the sides? Well, opposite sides are congruent. Opposite sides are parallel. And then we have the one side that can be parallel and congruent, making it a parallelogram. Well, here we're looking at measurements, not the parallel point of it. So this tells us the reason we know is right here. We've got these little tick marks here. Technically, they should have put tick marks right here because one side being congruent is not enough. So we're going to draw them in, okay? So now that we have our tick marks for both solving for x and y, we're going to use the property that opposite sides are congruent. So solving for x, all we need to do is set 2x plus 8 equal to its opposite side, 12. And then we simply just use our 2 steps in solving. And then we divide. We're going to find that x equals 2. Solving for y, again, we're just going to set these equal to each other. So we have y plus 3 is equal to 15. Luckily, we only have one step to do, and that's subtract the 3 from both sides. We're going to find that y equals 12. Number 4, we're dealing with angles. So let's go look. We have opposite angles are, and we have that consecutive angles are supplementary. So we take a look at what we have here. Solving for y, we can solve it using the property number 4 up above. The consecutive angles are supplementary. But I like to go in alphabetical order here. So what I'm going to do is I'm going to start with x. To solve for x, we're going to use that opposite angles are congruent, and we're simply going to set these equal to each other. Okay? So we have 2x equals 50. When we divide, x is simply going to be 25. To find y, what we want to look at is that consecutive angles are supplementary. Okay? Later on, you'll probably start seeing me write CONS for consecutive or something like that to abbreviate, but I want to make sure I use this right now. What that means is 50 and y together will equal the magic number 180 that supplementary is. So I'll just do y plus 50. Then we subtract that 50 from both sides to find out that y is equal to 130. Now, buckle up. Number 5 has a lot of things going on here. A lot. So let's take a look here. What can we solve first? What cannot we solve first? Things like that. Because, let's go ahead and start with V. Now pay attention. Because this is a parallelogram, okay, pay attention to that. This is a parallelogram. Segment AD and segment BC are going to be parallel. What that is going to give us, alternate interior angles are congruent. So let's look at it this way. If we take these, we go ahead and take AD and BC and pull them out to lines, then segment DB, that diagonal, is going to be the transversal. And these two angles, 2V plus 3 and 42, are on alternate sides of that transversal, and they're interior to these two sides, making them congruent. So for V, we're going to have opposite sides are parallel. In this case, we're going to have alternate interior angles. So it's not really two properties, it's just the one property, but within that one property, it creates these alternate interior angles, bringing back, it gives like chapter 2 or 3 when we did parallel lines and transversals. I think it was chapter 3, don't remember. So, being the fact that these are congruent, we simply just set them equal to each other. 2V plus 3 is equal to 42. As my next pen starts dying. May have to do another switch here. So, take our 2 steps, subtract 3. 2V is going to equal 39. Make sure we're still on the screen. Divide both sides by 2. Yes, you will get a decimal. You can get decimals. 19.5. All right, now to solve for x. X is going to be right here. What we want to see is x we can go ahead and solve for, because right here, way back to chapter 1, we have a linear pair. Okay, so here, what property are we using? Not a new one. I've told my students over and over again, these things will not go away. We do have a linear pair that would be supplementary. So that tells us that x plus 71 is going to equal 180. So we just subtract, and we're going to come out with x is going to be equal to 109. Go ahead and write these in too, since we know that degree measurement. All right, let's look at, can we solve for y? We can solve for y. To find y, we're going to use the same property we did for v. Okay, y right here, we're looking at that same concept that we do have parallel sides. This time we're using the other pair of parallel sides as our parallel lines. And then segment AC is going to be the transversal, telling us that that angle BAC is going to be congruent to angle DCB. So down here, let's go ahead and make note that to solve for y, opposite sides parallel. Giving us our alternate interior angles. And we don't have to solve this time. We can just already see that y is going to equal 38. A lot of concepts coming in. All right, the last one we have to solve for, z. Let's look where z is. Z is going to be right here. Well, we don't have its alternate. We don't know what these two angles add up to. So what do we do here? Again, we bring in a previous concept that we learned when dealing with angles, and even, I mean, we kind of talked about it in the last set of notes as well, dealing with the triangle. We're going to use our triangle sum theorem. Okay, your triangle sum is going to tell you that all angles add up to 180 degrees. So here I have the 42, I have z, and I don't have this, or do I? We need to remember, look at this, we're also going to be using vertical angles. So I can make that a little bit prettier for you. So with vertical angles, that tells us that this angle right here is also 109. So now we have two of the three angles. So we take z, I'm going to put a line through it so it doesn't look like a 2, plus the 109, plus the 42. Three angles of a triangle add to 180 degrees. Or you can just add 109 plus 42, subtract from 180. As we all know, a couple different ways you can do that. This will end up being z plus 151. Then we subtract it, and we'll find that z is going to equal 29. A lot is going on. I highly encourage you to go back through, rewatch little bits of it just to help you out. Any questions, please ask your teacher, or you can even search other on my YouTube channel. You can see I should have some other videos about quadrilaterals.